Welcome to multiplying and dividing rational expressions. Let's begin. The essential questions we want to know are what is a rational function, and then what is the difference between multiplying and dividing rationals. We want to be able to answer these by the end of the lesson. So a rational is a ratio of two polynomials. For example, f of x equals p of x divided by g of x, where p of x and g of x are polynomials. So it's a polynomial divided by a polynomial, a ratio of two of them. So an example would be something like x squared plus 3x plus 2 over x plus 3. So this is a polynomial divided by another polynomial. So let's talk about multiplying rationals together. That means if we have two rationals, so that would be 2, there's a rational, and then we multiply another rational. So one rational times another rational. These are the steps. You're going to have to factor first, then simplify, then multiply across. So let's try this example. We've got one rational times another rational. We're going to factor first. That was the first step, was to factor. So x squared minus 9 becomes x plus 3 and x minus 3. You got to be good at factoring. X squared plus 7x plus 10 is x plus 5 times x plus 2. And then 4x plus 8, it's not a quadratic, but we can still factor out a 4. And then the next x squared plus x minus 12 is x plus 4 and x minus 3. So the first thing I did was factor all of the polynomials. Okay, our next step would be to simplify. So an x plus 3 on a numerator, an x minus 3 on a numerator and an x minus 3 on the denominator, those end up simplifying to 1. So that's why you're not really crossing them out, they become 1, but that's why we can cross them out here. And then I have an x plus 2 and an x plus 2, one on the numerator, one on the denominator, simplifies to 1. And then that looks like that's all I can do. There's nothing else that would simplify to 1. So then our last step is just to multiply across the denominator and the numerator. So x plus 3 times 4 divided by x plus 5 times x plus 4. There's no need to FOIL them out or to distribute. It's okay to leave them in this factored form. It'll come in handy later. So dividing rationals is similar. We just have an extra step at the beginning. We have to flip the second rational. Because when you divide fractions, remember that you end up multiplying by the reciprocal. So in order to divide fractions, you have to flip the second fraction, and then you're going to factor, simplify, multiply across. So here's an example of this. I've got x squared plus 11x plus 24 over x squared plus 4x minus 32, one rational divided by another rational. So the first thing I'm going to do is flip my second fraction because we want the reciprocal. Because when you divide, you multiply by the reciprocal. So now I'm multiplying by 8x minus 16 over 4x plus 12. Now that second step was to factor. So now I'm going to factor the polynomials. This is x plus 8 and x plus 3 over x plus 8 and x minus 4 times, now these aren't quadratics, but I can factor out an 8 here, x minus 2, and a 4 here, so I have x plus 3. And that next step is to simplify. So I have x plus 8 on the numerator, x plus 8 on the denominator, so they become 1. I have an x plus 3 on the numerator and denominator. And 8 divided by 4, 8 over 4 would become 2 over 1. You could put a 1 there, you don't have to. And then the last step is just to multiply across. And again, you can leave it in factored form. So the only thing I have left on the top is a 2 times an x minus 2. And on the bottom I have an x minus 4. So that's my answer. Go back and rewatch the examples if you need to. Don't forget to write your summary and your questions. Thanks.